Okay, hi friends. Well, today we are gonna discuss about that what is linear regression and why we are using it. What are the applications where we can use linear regression and the statistical portion of linear regression and the regression line. And if time permits, we could also see the code using Python to have linear regression with it. So let's start. Here is the definition of linear regression, that in this we can see the relationship between two variables. One is the variable under observation. So there are basically, suppose we are want to find the relationship between two variables. So one is called the predictor or independent variable, and other is called outcome or dependent variable. So as we know that in a particular data set there could be various column names, and these column names act as an independent variables, and one class name would be there, and based on any variable we can see that how changing of a particular variable is putting effect on the class variable. By changing a particular variable, that is called predictor, as much change as if we see that if there is much change by changing one particular column name values, or by changing one variable's value, if we see the significant change in the class variable, then we will say that it's a correlation between these two. Otherwise we would say that there is no correlation between these two variables. And this correlation can be positive correlation, or it can also be negative correlation. Now see where we can use the technique of linear regression. It is basically used to find out the strength of a variable, or called predictor, forecasting an effect, that is changes, trend forecasting of price, or risk analysis. We can find out the prominent factors or prominent variables based on which we can judge that risk is high, moderate, or low. And when we can use linear regression, dataset plays an important role to decide that which machine learning technique we should use. So whenever we are finding data in numerical continuous way, we can apply linear regression to check a particular variable strength as compared to class variable. And hence we can see that what is the temperature of a place on a particular day by comparing it with the previous by comparing the same day with the previous week, or with the previous year on the same day. We can see that this factor is more prominent to judge the temperature or forecasting of sales. So this is the uses and when to use LR, and the complexity lies between O of n to O of n square. This is capital O. Let's move to the stats part of linear regression, that how it works basically. So let's take a small data. We are having x-axis data and y-axis data. As it is describing, x-axis describing speed in miles, and y-axis describing time taken in hours. And here on the right hand side we have plotted, and these are the points we have plotted corresponding to x-axis and y-axis. X is in this horizontal way and y is in the vertical way. Now we need to draw a regression line to see the relationship between x-axis variable and y-axis variable. And we know the equation of line is y is equal to mx plus c, where m is the slope of the line and c is the intercept. So intercept tells us the point and the y-axis where our line should go, and see m we are just calculating now. For that we need to calculate the mean of x and mean of y. It is simple, 1 plus 2 plus 3 plus 4 plus 5 divided by 5, as these are the 5 occurrences. And to get the mean of y, 3 plus 4 plus 2 plus 4 plus 5 divided by 5, and these are the values we have got. So to calculate the slope, we can use the already having formula, that is summation of y minus mean of y divided by summation of x minus mean of x. So we are calculating here, the value of y is 3 minus mean of y we have calculated previously is 3.6. Here mean of y is 3.6 and this is the value of y. So we will do 3 minus 3.6, 4 minus 3.6, 2 minus 3.6, like so on, to get this particular term. And in the same way we will calculate this term, x minus mean of x. Here each occurrence of x will be minus by the mean value of x. Mean value of x is 3, so every time we are using 3 here in the minus term, and these are the different occurrences at the x data. So it is 1, 2, 3, 4, 5. So in this way we have got the value of slope is 0.4. Now we need to calculate the value of intercept, that is c. So by putting in this formula we will get the same, mean of y is equal to slope multiplied by mean of x plus c. So we are putting the value of mean of y here, we are putting the value of slope that we have just calculated, multiplied by 3. 3 is nothing, just the mean of x, here it is, plus c. In this way we get the value of intercept, that is 2.4. Now in dataset we are already having the value of x and corresponding value of y. Here by using the linear regression we have calculated all these terms, and now we need to predict the value of y corresponding to the value of x. So value of y predicted is equal to slope multiplied by the value of x plus intercept. So we will do here for all the occurrences of y. So y predicted is equal to 0.4 multiplied by 1 plus 2.4. Intercept is constant, so 2.4 in the every term. Slope is also constant, so 0.4 is in the every prediction value of y. And this 1, 2, 3, 4, 5 is the value of x that we have put in this equation, and this is given in our data set 1, 2, 3, 4, 5. So we have taken that from here, and now we got the predicted value of y as well. Up to this time we are having value of x and y in the data set given. We have calculated the predicted value of y based on the existed value of x. So we are having the actual value of y from the data set and predicted value of y that we have just calculated. So we need to find out the difference between the predicted value and the actual value that existed in the data set. So we can say, after finding the difference between actual value of y and predicted value of y, that how much good relationship is between the two variables, that is x and y. So this is the same I have told. So we need to find that the regression line what we will draw, how much good it is and how it fit our bill. So see, for that we are having a term, goodness of fit. R squared value is statistical measure of how close the data are fitted to the regression line. It is also called coefficient of determination. High value of r square is good for the model, and this is the formula to calculate the r square. 1 minus summation of y predicted minus y mean square divided by y actual minus y mean square. So we can calculate y actual minus y mean. We know y mean is 3.6 and actual values of the y is given in the data set, that is 3, 4, 2, like this. So we will get the values of this term as 1.4, and to get r square, next term we need to calculate y actual minus so this is calculated. Y actual is given here, y actual minus y mean is 3.6, and here we are getting it for every occurrence of y, and in the last line we are just squaring the term. So it is 0.6 square 0.36, 0.4 square 0.16, and so on. After summation, that means after summing up all these terms, we are getting 5.2 from here. In the similar manner, we will calculate y predicted minus y mean. Y predicted is, for the first occurrence, is 2.8 minus y mean is 3.6. So y mean is constant 3.6, 3.6, and we are taking y predicted for each occurrence. So by doing this, we have got this as a summation 0.8, and when we square this, 0.8 square is 0.64, similar to the every term we have done square, and we got 1.6. So by putting the values of ya minus y mean and yp minus y mean in the r square formula, we will get the value of r square. So like see, 1 minus 1.6, that is yp minus y mean divided by ya minus y mean, we got 1 minus 0.3, and it is 0.7. So on the basis of this value of r square, we can conclude that it is a good fit as the value is greater than 0.5. So it is not the coincidence that changing the value of x changes the value of y, but these are having strong relation between these two variables. If r square is equal to 1, means actual and predicted values lie in the regression line itself. So to find out good relationship in this case, other variable should be okay. So it's saying that if we get the value of r square then is equal to 1, so it is the best fit. So we will do the exercise will one by one with the different variables of the data set corresponding to the class variable, and the highest value of r square variable will be having the closest or strongest relationship between the class variable and that variable. So this is the summary of the thing. Like earlier, we have put the dotted on the basis of given data, and this line has been plotted on the basis of predicted values. You can see 2.8 is the predicted value, the line is at here 2.8, 3 is the actual value, see 3 is the actual value, 3.2 is the predicted value, 3.2 here is the predicted value, and the actual value was 4, so we have put it 4. So from actual value we have put the dots here, and by predicted value we have put a line here. So if this dot relies on the line, that would be a best fit, and as far as these dots will be there from the line, that will be called as a error. Okay, so So that would be, so these points and line, if they should be come closest to each other, that would be the best fit, and in that case r square will be equivalent to 1.